Hello, this is Chapter 6 quiz. This is problem number 33. So this problem, 33 and 34 are very similar. I'm going to do 33 for sure, and I'll try to get 34 done as well. I wanted to do this problem 33 because, not that I'm going to I probably won't test you on this, but I just want to use this as an example of how to use these calculators. I think the calculators are very useful. I just don't like the little handheld calculators. I think the ones on the internet are just so much better. In any event, here's the problem. We're talking about calories in fast food sandwiches. It says the number of calories is shown below. Check for normality. So we want to check for normality. What the heck does that mean? Okay, so let's talk about that. And then we're going to use calculators to actually solve the problem. Okay, so this was discussed in section 6-2. It's on page 334 of the 10th edition of the textbook. So when we talk about normality, the idea here is that a normal-shaped distribution, otherwise known as a bell-shaped distribution, that's only one of many different types of shapes. There can be all kinds of different shapes. The normal shape, or the bell-shaped curve, or bell-shaped distribution, is very, very useful. So many times what we want to do is we hope that our data is normally shaped, because then it makes the calculations a lot easier. So how do we do this? Okay, all right, and here's some of the motivation. I'll let you read that. Now there's different ways, or several ways that they check. The easiest way is to just draw a histogram and you just look at it. If the histogram is approximately bell-shaped, then we say that it's bell-shaped, it's normal. If it's not approximately bell-shaped, then we say the data are not normally distributed. Okay, so now here's another concept here, and that is so-called skewness. Now, he doesn't make it abundantly clear. The author does not make it abundantly clear, but I believe, if I'm not mistaken, you can still say that you are normally shaped and still have some sort of a skewness. Okay, obviously what you would really like, if it's perfectly normal, it wouldn't be skewed at all, but you can still be bell-shaped but have some skewness. Okay, it's kind of a judgmental call. In any event, here's the formula, the so-called Pearson Coefficient. You do the calculation, use a calculator to do this, and you come up with a number. It's 3 times, and then in the parentheses, the x bar, take away the median, okay, divided by s, the sample distribution, sample standard deviation. Okay, if the index is greater than or equal to +1, or if it's less than or equal to -1, in other words, if it's significantly away from 0, then we say that it's significantly skewed. It's beyond the scope of this book to go into all these details about when do you make these decisions and when can you not use the normal distribution. But for our purposes, all we want to do is have some ballpark idea. Yeah, it's approximately normal, and we're going to do that just based on the appearance of it, really. That's what he's talking about right here. Okay, so here's an example of what he did. Example 6-11. You do the frequency distribution, draw a histogram. Looks pretty normal. It's approximately bell-shaped. Okay, we can also test for skewness, but the mere fact that if it had a skewness more than +1, I don't believe that's a judgment call whether or not you can still use the normal distribution. He doesn't explicitly say one way or the other. Okay, here's another example in the book, 6-12. As you can see from the histogram, is clearly not a bell-shaped curve. Okay, and on this one, we're checking for the skewness as well. Okay, so give me a second here, pause this. Okay, so based on the text, what we're going to do is we're going to draw a histogram, and we're going to determine whether or not it is approximately bell-shaped. Well, it's very tedious to do this, right? I mean, to get graph paper and to do all this is, it takes a lot of time. You can use your calculator, I suspect, but most calculators are hard to use. It's so easy to do it with the internet programs. So I want to just demonstrate one to you, just to convince you of that. All right, so you go to we're going to find a program that does these histograms, okay? But you still have to type in the data, right? Or what you can do is you can create a Word document and copy and paste it. So that's what I did, was I just copied this, and then I right-clicked on it and then hit copy. Then I created a document. Let me show you the document I created. Okay, so then I just, the reason I have to put it into a Word document is these programs all kind of work together well, but not so much the ebook. So you have to create the Word document first, and then you copy and paste the data itself. So I just highlight that, right click it, hit copy. Okay, all right. So let me close this. All right, now let me find that program that I want to use. Okay, so all I did was I Googled it. I Googled graph a histogram, and I come up with, thousands and thousands of hits. Here's the one that I happen to use. It's called an Easy Histogram Maker. Okay, and it tells you what it's going to do here. All right, and it says here enter your values above. So I just click on that, and then I hit paste. Okay, all right. So there's all my data. I hit generate. Oh, and by the way, this particular one here is, there's just millions of them out there, but this one right here, it's kind of hard to say. SOC, shoot, I can't even say it, but there it is. You can see for yourself. Okay, there it is. There's the website for you. But like I say, there's a million of them out there. All right, so here we go. Here's the data. Oh, wait a minute. All right, let me try this again here. Give me 1 second. Okay, I did it again. Here's the data. I hit generate. And here's my histogram. Okay, so I look at this. All right, and here it is. As you can see, the tool has generated a histogram, etc., etc. Okay. All right. So you look at this, you say, well, I don't think that's very normal. I got all this stuff over here, right? So you would say on this one, for problem 33, you'd say it's not normal. It's not bell-shaped. Okay. Now, as far as the actual, as far as that Pearson coefficient is concerned, let's take a look at that. There's a formula for that. Give me 1 second. Okay, this histogram generator, it also gives you some of this information that you need. You need the mean and you need the median. Here's the mean. Oh, and you also need the standard deviation. There it is. So mean, standard deviation, and the median. Well, I take that back. It doesn't give it to you. Okay, so I'll have to use the other calculator for this. At least I don't see it off the top of my head here. Okay, so I went to this other program called Calculator Soup. It's a great program, or it's a great website, I should say. Just Google it, Calculator Soup, statistics calculator, and here it is. So I entered the data set here. I called it a sample. Whether it's a sample or a population almost doesn't make any difference. We're not. It's close enough for government work, either one. So here we go, sample. Here's what I get. I get a certain, here's the mean, here's the median. Okay, so now I'll take a look at that. Here, I wrote that out for you. This is using the Pearson coefficient. It's called PC. That's on that page that I just showed you a moment ago. Page 334, section 6-2. Okay, so here it is. It's 3 times, so it's X bar take away median. So this right here, X bar take away median, that just gives you an idea of how different is the X bar from the median. Is it way different or not so much different? How different is it? Okay, and then you multiply by 3 and then divide by the standard deviation, the sample standard deviation. Okay, crank that out, you come up with 0.386. So not so much. Okay, but we still say that it is not a normal, it's not bell-shaped distribution because of the histogram. It's the histogram that really answers that question for you. Okay, so I hope that helped you with problem 33, chapter 6. If I get a chance, I'll try to do 34 as well. And that's the end of this video.